Hey guys, it's Tiny Tom Logan back with another video for you, and today we're going to be taking a look at my first Kaby Z270i ITX motherboard and MSI with the first through the door with this one. So it's the Z270i, and I'm looking at the back of the box because it's a hell of a mouthful. Gaming Pro Carbon AC. Okay then peeps, so a quick up close look at the board. You can see it's only got two DIMM slots down the side, so DDR4 slots, but it's an ITX board, so there's not a massive amount of room. Talking of room, it's actually 170mm from corner to corner, and if you were to put this in an ATX case, if you were to take your ATX motherboard out, the top 4 screws on the left-hand side, that's how big this board is. It's literally only as big as the I/O shield, really, on the back. But while we're on the back, you can see we've got a PS2 port here, 2 USB 2s, DisplayPort, HDMI. You do get a USB 3.1 in both A and C. These two red ones here, these are USB 3, and then you get gigabit LAN here, Intel LAN as well. Then over here, this is a Bluetooth and a wireless output, and you do get antennas that come in the box. One thing that you can see just here, this green PCB is basically a mini PCI Express wireless and and Bluetooth card just here. Then you've got your audio here. When we come around a little bit further, I'll bring you in so that you can have a look. This is well difficult doing it backwards, but you can see that you've got some Japanese capacitors down at the bottom, these little gold ones, and then you can see the chip just here for your audio. While we are down this way though, one of the things that I can show you is that you've got, this is your USB port, which is kind of inboard. This is for your external USB 2. So if you were going to plug in your power supply, or you were going to plug in your AIO or something, this is the port that you would need to use. There is an external USB 3 just down here, so you don't need to worry about not having one. SATA connections while we're down this end. As you can see here, 1, 2, 3, 4 in total. We move further around, you have your 24-pin power here. There's an 8-pin power just here. And then the weird one really is, if I bring it down so that you can see, there are your fan headers. So you've got 3 fan headers, and they're quite in the middle of the board as well. So if you were going to use it, I know I'm moving around, I do apologise. If you were going to use it, I would suggest that you get some PWM extensions maybe, or splitters, just to kind of clean your life up, and then you'd be able to tuck them up this side. If you're wondering where the BIOS battery is, that is actually what this little wire here is for, and it's hidden just in here. And there is a little wire there, so if you wanted to remove the BIOS battery to clear overclock or something, it's there. But there is a button for the clear the CMOS, which is here. Click, click. So that's all there for you. One of the other things as well is M.2, it's only got one, and it's round the back of the board, as you can see here. Now, one of the things I would say, if I just zoom you out a little bit, okay, so one of the things I would say is if you've got one of these, and you've got an ITX case, one of the things that you can do as a little project, if you've got a Dremel, is you've got your 4 screws here. I'd probably kind of go in maybe 10 or maybe 15 millimeters at the most, but mark a line in from the point, so 15 millimeters in, 15 millimeters in, and then you can quite easily cut out a hole, because then that will give you access to the back plate for your CPU, but then also access to your M.2. Now this is obviously going to be case dependent, because some ITX cases you might have the motherboard like almost sat on top of the power supply, so that's not really going to help you. But if you've got a case where the ITX board is sat upright and you've got cables that you can get behind the motherboard, if you can get access to the back of the motherboard but it's closed off, if you were to then cut that out, you'd then be able to get access to your M.2. So if the drive did die, or you did an upgrade, or you know, for whatever reason you need to get access to it, it might help save you from being able to, or having to take the whole rig apart, because let's face it, if you need to take the motherboard out, you need to take a lot of kit off, CPU cooler out, all that sort of stuff, so it might save you some time. So that's just an idea for you. Okay then peeps, so on to, we've got some graphs to show you, talk about some performance, but I'll also talk to you about my experience when overclocking the board as well, because I kind of go into as much depth as I possibly can do with that. Now, right from the start, when I tested the full-size ITX Carbon, that was one of the first boards that I'd actually tested before NDA, so it was maybe 10, 12 days before Christmas last year. So one of the things I did have a real big gut feeling about with that board is a lot of the limitations and slight issues that I was having, mainly with high-speed memory, which at such an early point in time wasn't necessarily so much of an issue. I did think that BIOS was the limitation. Now, the BIOS that I tested this on, which was a BIOS given to me by my MSI rep, is the E7A661MS.142. Now, one of the things I can say is this is going to be the last time that we're going to be reviewing a BIOS that is not publicly available on the website. There's been a lot of delays, and to be honest with you, with some of the other brands, when the BIOS arrives, they end up, they're just, we won't go into it. We'll save that for a video based on its own one. But what I am going to do, despite, I'm not sure how MSI are going to react to this, but I'm going to put a link to this BIOS in the conclusion of the written review on the OC3D website. So if you're having any problems with yours or something like that, you can go and get this. I don't know how long it will take for this to go onto the website. By the name that it's 142, I'm going to assume that it's the 1.4 version that's going to end up on the website at some date. But at this present moment in time, it's only up to 1.3. So to make it fair and annoying for MSI, if this isn't meant to go for the public, I'm going to share this with you, and there'll be a download link that you can go and grab it. So, on to the actual overclocking and stuff. Now, we do need to remember that this has only got 5 phases at the top of the board, so it's not ram-packed with like massive power ability or anything like that. But what I was most impressed with is two kind of sides to it. Now, with the memory, I did manage to get a maximum of 4,133 megahertz from the memory. But that kind of leans quite well because we are having slight limitations with the boards at this present moment in time, where you can only really get 4266 working. So I do have a 4,266 kit working with boards that have only got 2 DIMMs. That was why the some of the higher end overclocking boards are coming through with just 2 DIMMs. Yeah, I know what you're thinking about. So with this, we only managed to get 4133. It wasn't 100% stable though, and to get a stable kind of clock enabled, I did need to bump it down to 4,000 megahertz. So, but having the dual DIMMs does lean towards its favour in that respect, but it did do very well. One of the things that I did pick up with on the full-size ATX Carbon though was when you were running high-speed memory, especially XMP, the VCC IO volts and the system agent volts were not, a little bit high, they were dangerously high. And I picked this up with MSI as well. What they've done, and I don't know whether it's because of the BIOS that I'm running, and they've turned it off specifically, but normally when in the BIOS, when it's on auto, it will read the memory voltages or the voltages down the side that it's auto setting them to. Problem is what they've done with this BIOS is they turned them off. So the system agent voltage and the VCC IO voltage was not visible at auto. Now for me, that's not too much of a problem because then I go, weird, don't like that. And then I work out the manual voltages it can take. But the problem is, and this is why I'm hoping that this isn't going to end up coming directly out to you guys, but I kind of don't know at this point in time, but it does need mentioning, is if it's not showing for you guys and you go and buy yourself a 3866 kit memory for argument's sake, then you might not know that you need to manually set it. Otherwise, they are running literally unsafe volts. So by hiding it, it makes me smile like, but I also think it's a bit cheeky and kind of a bit narrow-minded that they thought I might not notice. So that's why MSI, you've got a big shouty, outy point out about it, that's a pretty shitty move. And I really do hope that you don't roll that out to the public, because putting those ridiculous amounts of volts through things and just hiding them from people. I even looked in Hardware Monitor, it doesn't show up there. So they've gone to quite some length to hide them. And I don't like that. So one of the things I would say, boys and girls, if you do end up getting your one of these and you get anything over about 2800 megahertz memory, make sure your VCC-IO and your system agent voltages are manually set. Now you're going to say to me now, what voltages do I need to use? Well, the problem is you always need to make sure that you can run the lowest possible that you can. So what I would do is I would start at 1.2 volts and work them back one at a time. So system agent, knock it down a bit, run some stability tests. Knock it down a bit more, run some stability tests. Wait till you find it wobbly bit and then go back up to the next one. If you do them one at a time, then you'll know that if you get to a wobbly bit, then you'll know which one it is. System agent is normally going to be slightly higher, but you can go right back down. For 3200, you might get like 1 point something, like 1.2 volts or something running. It's really going to depend on your CPU and how much voltage it needs, because they're all different. I've worked with 3 7700Ks and they've all needed different volts for the same overclock. They've all put out different temperatures for the same overclock, and they've all had different memory capabilities. So when I say the silicon lottery to you, I do genuinely mean you can't just use the same settings as your mates, because you might be cutting yourself short by a big margin, and this does and will affect the life of your CPU, temperatures of your CPU, and if it's temperatures, that could also mean the amount of noise that it's making as well. So I know it's a bit of a pain in the bum, and it might take you a little bit longer than you're used to, but if you're going to buy an expensive processor and you're going to buy yourself some expensive memory, sometimes you just have to get used to the fact that if you want to get the best from it and you want it to last longer, and then you just have to, kind of do it. Would you really want to be, if you had to RMA something for argument's sake, would you really want to be without your rig for a couple of weeks? I wouldn't. I'd rather spend a few hours getting it set up and then know, peace of mind, that it's going to be all right. So massive tangent, but this is something that I do need to make a dedicated video on, showing you exactly how to do it. But the problem is all the boards and BIOSes are so wildly different at the moment. I'm hoping that we're going to get to a period that they're going to close up so that I can make a decent video about it then, because I cannot make one for every board or even for the 3 big brands. I just don't have the time about it. And to be honest with you, the amount of questions that end up spinning out of it and the amount of people getting funny about me not answering questions within 20 minutes on YouTube is just ridiculous. So you do need to go careful with that, but I did turn them right back down, and for 4000 megahertz memory I was comfortable at 1.22 for the system agent voltage and 1.2 for the VCC-IO. Like I said though, I've got a different CPU that I could drop it in and it would be totally different. I know I've got one which will run less. So yes, and the different one is an i5, amazingly, it's the wrong way around. So you do need to be careful with that. So we got 4000 megahertz running. I did manage to get a screenshot for 5.1 gigahertz at 1.4 volts for the CPU, which was brilliant. And we also managed to tie the two in together as well, which was epic. So we ended up getting 4000 megahertz running with decent timings and stuff as well. It wasn't like all the sub-timers and everything were slackened off, as you'll see when we do the memory results in a bit. And then 5.1 gigahertz on the CPU. So the final overclock we got in the end was 5.1 gigahertz on the CPU, which we got with 1.35 volts, which was pretty good for this board, like I said, with those limited power phases. And then 4000 megahertz on the memory, all tied in nice. One of the things I did notice though was the load line calibration, which the load line calibration is meant to stop V-droop. Because when you put a CPU under load, you can notice if you open CPU-Z and you get your V-core that shows up there, like your voltages, it can dip. Now one of the things I did notice is the load line calibration on this. There was only one setting. Literally it was auto or setting 1. And with it on setting 1, although auto would have done that anyway, 1.35 volts did go down to 1.3, I think it was 1.32 volts, but then also did go up to 1.39 volts. So the load line calibration on this is a little bit wild, for want of a better term. They do need to get that in. I would be expecting to see like nothing below 1.34, and then I wouldn't want to see anything above 1.36, and that would be like a standard. I would not want to see beyond that, because you want your voltages to be as level as possible so you don't get any dips which can cause instability, and you don't want any unnecessary spikes either, because the unnecessary spikes are just going to add heat, and your CPU just might not need that spike, you know, at that specific moment in time. So they do need to get the load line calibration fixed. I did manage to get it all stable though. I personally think that if it wasn't for the load line calibration being a bit woo, I think I probably could have driven the volts down more, but I was unnecessarily having to hike them up a bit to allow for the droop that was setting in, where it was going back down to below what I was really setting it to. So that's another thing they do really need to get addressed in the BIOS fairly quickly. But again, it did quite well. And you need to think that, I know look, people are going to be shouting at the screen, we don't care about 4000 megahertz memory and we don't care about load line calibration, but I'm a reviewer. I need to talk to you about all these finer details so that you can decide whether it might be the right one for you. You might not care about load line calibration, but you know, somebody else, that might be something that they're, you know, voltage stability might be a big thing that they're looking at. You might not want to buy 4000 megahertz memory. To be honest with you, if you bought this board, I don't think you'd want 4000 anyway, but it is the difference between the boards that we need to pick out. And to be fair, there's not a great deal to pick between them. So that when one performs better in a certain area or performs worse in a certain area, that's where I need to kind of like chime in and tell you about it. So into the graphs. And before we hit the graphs, don't forget, we do lots more tests on the OC3D website. There's a lot more graphs. There's like another 12 graphs that you can go and have a look at, with all the boards in there that we've tested as well. So you'll be able to see the original Z270i Gaming Pro Carbon ATX board from MSI, and you'll also be able to go and look at some of the other brands that we've done. We do have other stuff coming in from MSI and other brands. It's kind of a constant trickle. So you'll be seeing a lot more stuff over the next few weeks, hopefully before the influx of Ryzen stuff kicks in. Right, so I know what people are thinking. So Cinebench 15, this is a really nice one because it's CPU grunt, 3D rendering. So it's a good way of really stressing the CPU out, and it gives us kind of really nice numbers that you can look at as well. Now, one of the things that we can say is it's pretty midships for the stock, which is a really good thing. But also, take a look, there's not a great deal between, there's a big bulk of them that go from kind of 1004 points and then up to like 1015 points. So when you look at it, there's 15 points between most of the big ones, for want of a better term, before we hit into the overclocks. And then when we do go into the overclock, it comes in at number 3. And the ones that are above it are kind of like, one is a £250 ATX board and one is a £300 overclocking board. So when you drop an ITX board in third place in that graph, it is actually quite epic. When we move on to gaming, I have to admit, it didn't seem to really grace the gaming stuff very well. You can see it's kind of at the bottom of the graph, which was the overclock, which was weird. I actually did go back and turn the overclock down to see if we could rectify it. It just didn't, there was just something that wasn't quite right when we were starting to play around with it. It could quite literally be something that I'd done, but with all of the other graphs, they responded really, really well. So with this, I'm not quite sure. I'm going to say, I go as far as to say, I reckon that will be fixed with a later BIOS revision. I seem to say it a lot, but it's just in hope that they do kind of sort it out. Like I said, I did turn them back, but I literally had to turn it back so much before the scores kind of went back up again. We were pretty much back at stock. So I'm not sure what it is. Maybe it's something to do with something, you know, not quite being right with the PCI Express tie-ins in the BIOS or something. I don't know. But the numbers are there for you to be able to have a look at if you're interested. If you're just going to be doing gaming and you're literally just looking for frames per second, Weirdly, with the BIOS that I've got, this one, don't overclock it. But that's only at this present moment in time. But this is also why whenever you do overclocking and testing on your kit, you need to do it at stock, and then each time you make a change or turn something up, you go back and run the tests again to see whether you've gone too far with it, or you need to bring it back a little bit, or whether, you know what I mean, you're just not really seeing any benefits from all the extra work that you're putting in. Real bench, this actually did really quite well, because when you have a look at the stock one, it's pretty much second place, and it did really well. And then with the overclock, it was second place as well. And when you look at what's above it in that graph, it just goes to show how well this did with the overclocking play, which does then kind of lean back to my talking about the gaming. Something what obviously isn't quite right with the gaming side of things on this board at the moment, because so many other things, when you're looking at the CPU and the memory and stuff, it does just go really well. And talking of memory, when we move on, memory bandwidth, this is all about. So what you need to think about is the stock one at the bottom was 3200 megahertz, and all of the stock boards in this were with the same memory. And what we do is we just enable XMP with a 3200 megahertz kit and run our tests. The overclock really depends on what the board was capable of. So this was capable of, we were running the tests at 4000 megahertz. The one above it was being benched at 4,266. So again, when you look at that, in this line of graphs, you can see quite how well this did. One of the things I can say is the two below it in this graph were also being benched at 4,000 megahertz, and this board did actually do quite well with that. I'm going to say that's because it's only got dual DIMM, and the ones that were below it were on 4, but you still get the point that I'm trying to make, that you know, the design of this board and, you know, the fact it's all crammed in and stuff, actually in certain aspects can end up doing it a favour. So, on to a conclusion. First things first, price. I've just looked on overclockers before making the video, so OC UK, and it's $172.99. I have had a look at one of the other brands, ITX boards, that's going to be coming out, and that looks like it's going to be coming in at 200 quid. So there's a £30 difference. I've obviously not tested it yet, so I'm not going to compare them on anything other than price at this given moment in time. At 30 quid's a fair old chunk. That could be a 15% difference. So, things I like about it. The dual DIMM definitely has helped with the memory. The BIOS has helped with the memory as well. The overclocking is much better as well. So there's lots of good things to talk about. You've seen in the graphs on everything other than the gaming, it did do relatively well. Midships, sometimes it was even arguing for the top spot. Never quite kind of got there for the overclocking, but you know, with some of the other overclocks we've done on the other boards, specific overclocking boards I might add, there was a good reason why it wouldn't have got to the top. The fact it made such a strong second and third place appearance is actually really a good thing to say. Things I don't like about it are, they've obviously turned the VCC I/O and system agent voltage auto from showing up in the BIOS. So rather than fixing the problem, they've kind of hidden it, which is pretty shitty. And I definitely have picked up on it. And the reason why I'm drawing so much attention to it is because they have to get that fixed. With the ATX board, I was seeing unhealthy amounts of auto volts going in, and they were making all these excuses about maybe it's because we need to make sure that it can work with rubbishy memory kits. To be fair, once you get up to those kind of voltages, I don't care about rubbishy memory kits and rubbishy CPU volts. They were unsafe volts, and if your board cannot cope with these settings without them being unsafe, then it shouldn't, you know, it just shouldn't work, and people should be able to do it manually. Also, if your board needs to put unsafe volts through, you need to put a massive flag up so that people know to go in and try and manually change them, rather than just assuming that people are going to be all right with RMA in their CPU, or maybe even the board at a later date, because stuff started to die because you've been sticking 1.35, 1.4 volts through something, which I might add goes to an unsafe level of voltage, normally around the 1.2 mark anyway. If you go into the voltage on this and change the VCC I/O or the system agent voltage above 1.15, it goes yellow stroke red to tell you that you've gone beyond the safe limits. So these are all the things that I'm trying to, bring to your attention, and the fact that I haven't got a clue what it was putting through on auto is kind of unnerving. Also, the load line calibration is pretty pants. They definitely need to get that sorted out. There's far too much of a range going through, so that's something else that needs to be addressed. The only other real kind of gripe that I've got is the fact that all your fan headers are all down the I/O section here. Now, I know you can easily kind of route the cables up this way, but I think it would have been better to have had, like the CPU one kind of maybe moved up and around. I understand with an ITX board, it does get complicated to be able to do and be able to fit everything in. But it just seems like, chucking all three of them all in a line just seemed to be, kind of a little bit woo, for want of a better term. But other than that, the performance when we got there and I manually, chimed and tailed all those volts in, I knew where stuff was going. It is actually a really good board. I would like to see the gaming performance with an overclock at least stay the same, if not go up like the other boards, because something wasn't quite right there, and only their engineers are going to be able to sort it out. But at the end of the day, it did do very well. And one of the things I can't kind of stress enough is how far they've come since I tested the original board. There is a remarkable difference between what I tested on that day and what I tested today, and it does show that they are putting the effort in to get stuff follow through. So if you've got this board and you've only got the 1.3 BIOS, which is the current public BIOS, if you fancy trying something new, don't forget to go to the conclusion on the OC3D website, and I will put the link in for you. And also, maybe if you're even running one of the old ones and you want to compare stuff, you'll be able to go and have a look at the BIOS, because it will just be there forever. Unless MSI gets funny and demands I take it down. But anyway, it's just to open up the fairness and that sort of thing. So yes, I personally do quite like it. The award that I decided to give it in the end was the OC3D approved award. And what I mean by OC3D approved is if you were to have a short list, so maybe 2 or 3 boards, it definitely has earned its place to be given some consideration. What you then need to kind of do is just think about price, performance, the features, and then maybe the layout and the aesthetics, because it does come down to a lot of aesthetics, where things are going to be on the board, how it works. But it definitely deserves to be given some thought, and when choosing a motherboard, I would look at the way things are laid out, the case that you might want to put it in. Does the aesthetics work? Are you going to like the fact that it's got lights down the side, and you might be able to, raise an accent in your case, pop an extra bit of colour in there. Maybe the fan headers are going to be a problem. Do you need to think ahead? Do you need to get some PWM extensions to be able to get your fans in, nice and tidy? Do you need to get yourself a PWM splitter so that the CPU fan header then goes on to the 2 fans of your AIO? There's lots of things for you to kind of consider, but OC3D approved award, because like I said, it definitely deserves some consideration. Maybe we should call it the Give It Consideration Award. I don't know. Put some comments underneath to let me know what you think the alternative wording of that award could be, because to be honest with you, OC3D approved, it's still not sitting well with me. Anyway, looking around, this has been Tiny Tom Logan with his first Kaby Z270i ITX board. Has done really well. It's actually surprised me how well this one has done, but for now at least, this is Tiny Tom Logan with another video for you.